Hello, everybody. Welcome to our webcast, where we will be discussing key takeaways from the 2024 Databricks Data and AI Summit. To set the context for the day, here is our agenda. We'll begin with a brief introduction to who we are, followed by the main topic areas and takeaways from the Databricks Summit, and close with a summary and a view ahead. For a brief introduction, my name is Tim Tague, and I'm a data and AI consultant here at Thorogood, based out of our Boston office. I'm joined from Philadelphia by my colleague Ben Dunmire, who is a data and AI consultant as well. On the right are a few snapshots from the Databricks Data and AI Summit in San Francisco, which we attended in June, and we are excited to share our takeaways with you here today. To share a bit more about Thorogood, we are a global, independent consultancy specializing in data and AI strategies, solutions, and services. We approach data and AI initiatives by focusing on business goals and opportunities and overlaying on that what is possible from a data and technology perspective. Ultimately, we identify and deliver ways to address those business objectives through expert application of data and AI. As mentioned, we are a global company with offices in London, Philadelphia, Boston, Singapore, Sao Paulo, and Bangalore. We offer a wide range of services from end-to-end implementations to architecture and strategy design and end-user enablement. Additionally, we are partners with Databricks and have continually leveraged Databricks to deliver solutions and advise on strategy with our customers for the better part of the last decade. We have a number of Databricks champions within Thorogood and are part of the Brick Builder program, as can be seen here, and continually are completing Databricks certifications throughout our company. All of this, along with attending the Databricks Data and AI Summit last month, are ways we stay skilled and up to date on the latest Databricks capabilities and can help our customers apply them to achieve their business goals. We see a lot of value in Databricks and are equipped to deliver it across all cloud platforms and integrate it with other key vendors, both big and niche. The technology independence of our firm gives us the ability to maintain a wide view of the market and consider how to apply a wide array of tools to the best effect, depending on the problems or objectives at hand. The Data and AI Summit gave a great avenue to hear about Databricks and others' latest product offerings and align with the direction of Databricks in the wider data and AI industry. I'll jump into our reflections from the 2024 Data and AI Summit, focusing on key announcements, applicability and use cases, and then our takeaways, recommendations, and questions moving forward. First, we'll start with Unity Catalog. This is really a main focus for Databricks, as it is the key integrator and enabler for actually leveraging data and an enabler for other tools within the Databricks stack. Some of the big announcements from the summit. First, the open sourcing of Unity Catalog. Live at the event, Databricks open sourced Unity Catalog, allowing for broader industry participation. This sticks to their roots on open source capabilities and interoperability, which is ultimately for the better of the community. This also fits in their strategy as having Unity Catalog as a single point for data access and governance, so they need that connectivity. This will ideally lead to better integration with downstream BI and analytics tools as well. Next, Lakehouse Federation. With Lakehouse Federation, you can connect and run queries against multiple data sources without needing to migrate all the data to Databricks. Instead, Unity Catalog supports connections with many systems, such as MySQL, PostgreSQL, Snowflake, Redshift, and more. Powered by Lakehouse Federation, there's also a new and improved Catalog Explorer, which is improved off of the existing Data Explorer for browsing, for access control, and for querying against your data. Third, Lakehouse Monitoring. What Lakehouse Monitoring provides is built-in automated quality checks. For example, are there a lot of nulls in a column or in your table? Has a table not been updated for a long time? Additionally, you can add your custom checks as well. Lakehouse Monitoring provides rich dashboards about the data quality, and results are stored in tables which can be viewed and assessed. Lastly, attribute-based access control. There's improved attribute-based access control within Unity Catalog, where you can set tags on your data at any level. And there will also be automated tags based on patterns that are discovered within your data. This ultimately helps with data privacy and security. Regarding applicability and use cases, Lakehouse Federation and that connectivity to external sources within Unity Catalog allows for much more ambitious projects using more data sources without having to bring all the data into one place. The new Catalog Explorer will help everyone, including non-data professionals, to explore data within the new UI. The improved privacy really improves the ability to secure personal information or other sensitive data in an easy manner and have it propagate throughout. And lastly, with regards to data sharing, Databricks objects can be shared and presented to non-Databricks users and vice versa, just really allowing for easier ability to share data. Some takeaways and recommendations and thoughts moving forwards. First, on building versus buying. You'll see this takeaway and trend throughout some of our content today, but do you want to buy this data quality features or do you want to build them from scratch yourself? This has always been and will continue to be a theme and a question to focus on, but for much of this automated data quality functionality, automated privacy rules, do you build this yourself or do you buy the product? Always a trade-off there. Regarding migrations to Unity Catalog, what we're seeing is migrations have been more difficult than expected, and it really needs a careful hand in planning and establishing things like volumes and connectivity, establishing governance standards, handling multiple environments, understanding what functionality may be decommissioned within Unity Catalog, and more. This is an area we're happy to share experiences on migrations we've done and are actively working on right now. We're seeing it's pretty easy for new development to leverage Unity Catalog, but really there's a need for a good approach for migration of existing systems given the level of code change within Unity Catalog. Lastly, there's a question of if other tools like BI tools will enable Unity Catalog as a source. That's really the bet being made by Databricks by open sourcing Unity Catalog. The hope that other tools will adopt it as a source and everything will be centralized to Unity Catalog. Might be a question of if this leads to lock-in within Unity Catalog, and to an extent maybe, but always making sure you're storing data in general formats. But it's always something to consider with vendor lock-in. Next, Databricks Mosaic AI. So first, a bit of background on this and what this is. Actually, at last year's conference, Databricks announced the acquisition of Mosaic ML. And what we're now seeing is rapid growth and integration of Mosaic AI, which is a unified platform within Databricks for developing, hosting, and monitoring AI and ML products. Some key announcements. First, the agent framework, which is a set of tools in Databricks to help you build, deploy, and monitor agents like RAG applications. RAG, or Retrieval Augmented Generation, is a Gen AI design technique that enhances large language models with up-to-date information, proprietary information, and more. I'll speak a bit more about RAG and other LLM approaches here in a minute, but Mosaic AI Agent Framework set of tools assists in the building, deployment, and monitoring of agents like RAG. Second, more multimodal, allowing a RAG architecture or other architectures to work for many input data types, not just tabular or structured data, but also written text, images, videos, and more. Regarding applicability, this really allows for us to build AI products within just one platform on Databricks, managing your governance and data through Unity Catalog, and utilizing any LLM architecture of your choosing within Databricks Mosaic AI, from prompt engineering to pre-training from scratch. Again, I'll talk more about some of the LLM architectures here in a moment. Additionally, creating and deploying AI tools to allow you to retrieve information or carry out limited or independent tasks easily within Databricks Mosaic AI. And lastly, with the multimodal approach, being able to explore not just structured tabular data, but all sorts of other data you may have internally or have access to. Regarding takeaways and recommendations, again, this build versus buy thought. So on the left here, you'll see a chart from Databricks with the trade-offs and complexity of the 4 different main architectural patterns to consider when building LLMs. But ultimately, Databricks and Mosaic have wrapped a ton of features into these out-of-the-box services. You could code it all from scratch if you wanted to, but there's the trade-off of do you pay for more for the out-of-box feature, or do you invest the time and really where you need the expertise as well to build, maintain, and adjust these tooling. Within Databricks, all 4 of these architectural patterns are available and possible. I'll share more details on the specifics of these here in a moment. Second, how to best move from POC to production. 85% of AI use cases have not yet made it to production. This is a big focus or a big data point Databricks has shared. It's really a big focus on getting these use cases off the ground, which will serve value, and it's hard to know often in early stages. Additionally, there's always concerns with governance, security, and privacy, and it's important to take a stepping stones approach to identify places to start and build from the bottom up. Lastly, regarding the ultimate question of how can AI agents and large language models improve your workflow, and what types of models to use. Share a few more details about these 4 architecture structures that I have mentioned throughout, ranging from the least complex to the most, but all have their benefits and specific implementations. First, with prompt engineering. So you can consider a user providing feedback to an agent's answer as prompt engineering, where you look to customize prompts without changing the actual underlying model. It's not done a whole lot. We aren't seeing much true prompt engineering, more some of the other approaches, but is one structure. Second, retrieval augmented generation, or RAG. This is really good when context is included in a question. It's not as good at summarization, but RAG is really useful when there's high volatility of changing information. So if you're constantly getting new data, weekly data, quarterly financial reports, whatever it may be, because the model isn't actually trained on this new data. It just receives the best information from data that is relevant to a specific question or task. Third, fine-tuning. This is really best when a very specific formatted response is desired. When something is very specific to a given company, internal acronyms, jargon, etc., you can fine-tune to adapt an existing all-purpose LLM. Lastly, pre-training from scratch. This is really building a new LLM model from scratch. Best used for when there is a need for very detailed and specific domain knowledge that a foundational model simply doesn't have enough of or doesn't have access to at all. A big part of this overall idea is the idea of compound AI systems, which there's a paper written by some of the Databricks founders that's very interesting, and explains that to get the value and really build these language systems, it is likely a true system, meaning pulling on the right parts and different architectures in an end-to-end integrated flow. We're seeing this on a few use cases now, including engagement we are working on where we have trained an agent on quarterly investment reports from our clients' investment funds. Using the unstructured and semi-structured text data from PDFs, we've allowed for users to interact with this data via a chatbot interface, asking questions ranging from which fund was the top performer this past quarter to what is the summarized outlook on the AI industry from our top 3 funds. So very powerful and very interesting approaches and different levels of complexity across these 4 main architectures. I'll now pass it over to Ben to continue with our reflections, starting with some thoughts on Databricks AI BI.
Good stuff. Thank you, Tim. We really felt the Unity catalog and then all the announcements around AI, generative AI, was the right place to start, just given the breadth of updates from the summit, but also the impact. But obviously over a packed 3 days, there's a lot of other things to jump into. So I'll pick up on a few other topics and share our perspective on them and things we heard from the summit. So the first one Tim mentioned, AI BI, and that is not just the acronym of artificial intelligence and business intelligence, but the name of a sort of new product or module that Databricks have rolled out. And it's sort of a revamping of Databricks SQL or Databricks SQL Analytics, which people might be familiar with. So the dashboarding functionality has existed, has been sort of revamped and remodeled. And they brought in kind of a new AI backing, highlighted by one component, which is a Genie. And you can see at the bottom of the screen a few screenshots there of it. The one on the right being a quick chat I had with Genie. So really think of it as sort of end user kind of dashboard experience, along with the kind of chat interface that a lot of people are sort of striving for. And Tim mentioned compound AI systems, and really what Databricks has done is taken their own advice and built that as part of this AI BI tool. So they are treating their kind of AI BI product as a compound system. The thing, and I'm almost more excited about, is the advancements in data warehousing. We might not always think about what Databricks can do as a data warehouse. I guess by definition, it's a lake house, which combination of data warehousing and data lake. But they've really put a lot of focus toward the functionality features to enable data warehousing in the traditional sense. So grabbed a quick screenshot, as you can see here, of features that have been released recently and then a few upcoming ones. And a lot of them will be familiar because they're things you would kind of imagine and expect from a data warehouse platform or tool set, really. So it's really helpful to see kind of Databricks going in this direction naturally. And for us, we have to be able to take advantage of how we can use these sorts of things to engage with a huge amount of data and information stored in lakehouses and actually make it accessible. And I really think that's what naturally this is focused at. And we have to think, how do we take advantage of it? A few of the features that are particularly interesting to me, some data masking, and that's covered in Unity catalog as well, data masking to handle private information. There's a number of new functions around spatial intelligence, AI, that have sort of been baked into the Photon SQL engine. And then also, and maybe it sounds simple, but creating ER diagrams, entity relations diagrams, which it just kind of helpful features that are building out the data warehousing sort of stack. Build it out a bit here. So use cases, one, exploratory data analysis. So that ease ability to concoct a quick dashboard or look at data or profile data, maybe in combination with business partners on the fly, can be pretty helpful. There's a question, is it something that replaces what do you think of as traditional reporting tools, a Power BI, Tableau, Quick Looker? It's hard to say right now, obviously just being released. It could be a supplement. I think right now seeing as a quick supplement. I think we're all almost hearing and everybody's talking about that sort of holy grail of being able to chat with your data, be able to chat with modeled and structured and unstructured data. And Genie is really Databricks' proprietary build of that. So we'll have to see, is that something that is the leader? Is it leading the way or folks building their own kind of models to do that, to use Genie directly in the Databricks interface or embed in another tool set. The thing to think about is bringing that familiarity of data warehousing to lakehouses. And that sounds kind of weird to say because it is, lakehouse is partly a data warehouse, but really seeing the ways in which technical users, analysts, report builders, anybody are further able to actually engage with data in the lakehouse. So it's part of the full picture of Unity catalog of data warehousing features. How are we really getting to access to write queries to build reports on top of vast data lakes? A few things to suggest taking away from this, and you kind of hear everybody say this, and the folks at Databricks made it a point. Your AI and analytics are really only good as your data, as good as your data quality, the completeness of data, the fidelity of data, the metadata tracking, and the governance strategy. So we can really use a combination of the AI, BI, and data warehousing to help do that. One question I think it's been starting to be explored and documented is for Genie, where is data being stored? Where are the chats, kind of the information shared across those chats being stored? Are there any concerns with data privacy? It's a question that keeps coming up, and we just want to understand how that's working. And further evaluating, is Genie the right tool? Should it be kind of built in a way to adapt to different organizations, or will there be competing products that kind of fit for that chatting with your data? But ultimately, it feels like it's getting closer and closer to be able to do that. So the technology is improving. It's really on us to support the data. And then thinking about how data warehousing will help further bring access to data, and particularly analysts, SQL savvy individuals, to be able to work with vast amounts of information. So the next one I'll touch on is data storage. At the summit, there were a number of different updates, sort of led by Delta Lake 4.0, and then kind of within that, there's a lot of different features as you might expect. I'll highlight a few. It's sort of useful to know that those few things were announced, of course. One that was highlighted quite a bit is Project Uniform, somewhat fueled by the acquisition of Tabular as well. Actually, at the summit last year, Project Uniform was announced as part of the open source project, and then I think it just needed some advancement, some improvement to be completely usable. And the idea of it is that whether you're using Delta Lake, Apache Iceberg, or Hudi, there will be sort of an interoperable, fully understandable, a single version to be able to basically use these different data source formats. So it's really moving along the path that Databricks is and a lot of organizations have been saying of we want to store data in interoperable formats. It's something we definitely advise on. The kind of broader point I'd make is the Databricks and the open source community for a number of these things are constantly evolving. I'm going to talk about liquid clustering in a second, but they're constantly introducing new improvements and new capabilities and performance tuning. Some of it just happens behind the scenes. You don't even know. Some of it you have to be intentional about. So it's useful to recognize that and figure out how to take advantage of it, because it could help with challenges or limitations, or could give you a competitive edge. Some of the things I'm initially looking at, probably particularly focusing on large data sets or long-running processes, feels like a place where some technological innovation can help. Tim talked about multimodal data, and seeing how that fits in with the latest in terms of Delta standards, because you want to be able to use the best standards, of course, to have full access to that unstructured data. A lot of organizations will develop a COE or a similar type of concept to define standards and roll them out. I think it's ever more important to be on the cusp of these. There's so many different things. I mean, it's a ton of information shared just in a 3-day summit, and even beyond that, how do you keep track of everything that's changing, advise on it, assess what do we use, what do we not use? So I think advising customers to do that and do more of that as best as possible. A few takeaways, and I'll just do a quick demonstration. We still see distributed processing in the clouds chasing the low latency processing that you would expect out of an on-premise database, but it's getting closer and closer. The cloud really has the advantage of constantly changing, new enhancements, rapid product development. Databricks will talk about the number of product features that they release in a given period, which is kind of astounding number, really. I don't think we have much doubt in storing data in non-proprietary formats. Tim talked about lock-in, which I'll come back to. The question now is, how do we service it? So AI and BI and data warehousing, different formats. How do we bring it to people? How do we bring it to other tools that will allow us to visualize it or analyze it further? And I think the last point here, and I'll probably make this another time, is naturally Databricks as a product company recognize limitations or gaps in their tools, or even places where it's just implemented incorrectly or not as suggested or expected. They address it, and then what we're seeing is they're giving sort of the option for us to let them optimize it, them being Databricks, the technology, or a combination of manual intervention. But they're really looking for places where they can bring intelligence, oftentimes using AI, to optimize the storage of data sets or optimize queries or whatever it might be. So it's helpful to know that they're focused on that. And it's also a little bit of that question of how much control do you want to give to just behind the scenes, a black box of what's happening. So that's part of the reason I wanted to show a quick demo here, and I'll get that pulled up. You might very well be asking, of all the things that are shared in the summit and topics, why liquid clustering for a demo? I think it's an interesting topic, and if you're interested in other demos, there's a ton that was covered obviously in the summit and thereafter to look at. But I think there's a couple helpful sort of themes to pull out of it. So to explain this demo, and to be very quick here, I just want to understand liquid clustering, and the idea of it is sort of an optimized way to really store information in Delta Lake and organize information. So I've been a bit lazy and just used the inbuilt sample New York taxi information, which is taxi pickup and drop off in New York City, I believe. Added a few helpful columns, so date columns here. And the first thing I've done is I've just written it using really one of the standards, particularly for time series data, which is partition by. So where you're physically organizing by defined columns in the data set, often time series, it's most applicable, helpful for incremental logic. So I've done that. I've just written out this data set. And then here's a bit of code to analyze it. It's just pulling back the number of files and overall volume just to give us a point of reference. So say about 180 files, and then hard to see the number there, about 100,000 bytes. So if I actually look at what's physically happening, we can see, I guess, as you would expect, that it's partitioned by year and then month and then day. And then in here is pretty small files. So normally you're wanting to get around about 100 to 200 megabytes. We're obviously way far off from that, but probably because I've partitioned it so much, there's only so much data for these days. So that's partition by. We do something similar using liquid clustering. Now the coding of it's a little bit more complicated. I think this is going to evolve and really improve. It's a couple of different steps here, but really it's just writing it and then using through Unity Catalog to define liquid clustering, and then you can declare the columns, or you don't have to declare the columns, but I've done the same thing, and then just optimizing to basically apply that liquid clustering. And I've done the same check, and don't take this as like, oh, this is definitive proof that liquid clustering is the best. I've done a kind of very simple example and not really fully thought through in terms of a full evaluation, but it's a lot less files and it's about half the volume. If we look at that physically, it's just a couple of files. Bigger size was mentioning that 100 to 200 megabytes stored here. So I guess what this is just showing is normally we would want to organize data in a way that we think makes the most sense. In time series, it's usually by time. We sort of taken that out of our hands and said, Databricks, Delta, really figure out how to sort this data, how to organize it, how many files, all that, and you handle it. So I think that's the point beyond this being an interesting thing and something we definitely advise looking at and seeing about how to adopt, is that there are constantly changes and capabilities being added behind the scenes that might happen by default or we have to take advantage of. And I guess I'll just log in here. Just to look, I'm in Unity Catalog at the table itself. I'll just click on that table. You can actually see some of the features, and Tim mentioned Unity Catalog a bit, suggesting descriptions, a number of other things here. So a lot with Unity Catalog. Really, the only place you're able to see is in some of the minute details of the clustering columns and a few other things here that are telling me it is liquid clustered. So I imagine this will move a little bit, but just wanted to show where we can actually recognize it. So I hope that was helpful. Again, I think the bigger picture is there's a lot happening in the technology and products. We have to understand it, of course, to see how to use it. Some things will just happen kind of automatically because there's optimizations, but other things we can take advantage of. So moving from partition by kind of intently to allowing Databricks to take some of that out of our hands. I'll go through a few others here and then look to wrap us up. So serverless has been around for Databricks SQL, or sort of that endpoint, and they're now rolling it out for everything, for all compute. And I know they've done this using serverless notebooks a couple of times the last few weeks. So I think the actual availability will be quick. The real question is, what does a migration look like? What does a rollout plan look like? What are the right places to do it or not to do it? I think the main pitch here is Databricks helping with cost consciousness. So largely removing that idle time. I think that happens quite a bit more in lower environments actually than your production environment, where you might be letting clusters or compute running at different points in time. So you sort of like almost offer or direction of Databricks to help with our cost consciousness, but they are obviously wanting to drive more people to their platform, more solutions to it. A few things to think about. What's the privatization look like? We spend a lot of time, a lot of organizations to bring compute into network and privatize it. How does that work with serverless? Can you do the same sorts of things? What do migrations look like? Is there a place do you start? Do you start in your lower environments and move up? Do you pick certain workloads? And I think it's also a kind of debate of, do you want to give up some control, lessening the perceived complexity of, go in and just set up these clusters, I don't have to worry about them? or do we want some fine tuning of clusters of configuration? So it's another question of, do you give up some control and maybe give away some of the freedom, but you get back more automation, maybe less headache in some instances. All right, last one here, Lakeflow. So this is a newly announced, and you can see the screenshot as of now, just becoming available for a little bit of preview. So this one's upcoming. It's kind of a refreshed orchestration tool, or not really refreshed, but new orchestration tool. And you can sort of see Databricks are looking across the data and AI spectrum and seeing what else, what functionality do we need, what do we have to add, and looking at orchestration. There's 3 parts. Connect, which is a purchase I think Arceon Databricks purchased. It's native inbuilt connectors for ingestion, so connecting to proper source systems. Pipelines, which is being pitched as sort of data transformation, so I imagine bringing together Python, SQL, and other data transformation steps. And then jobs, which to me sounds pretty similar to the current workflows for actual end-to-end orchestration, I think built on Airflow. So really, I mean, orchestration can apply to anything. What I'd be particularly thinking about are places where you have particular limitations or gaps in your tool set now. Are there things that are causing issues or things that are causing performance delays or auditability challenges? And does Lakeflow help with that? I think I've been using workflows in some simple instances. That might be a place to start with Lakeflow is let's use a few small, simple use cases and just see how it works, see what it can help us do. A few takeaways. You can see Databricks wanting to give us the ability to keep everything within their walls of have all these features. That question is, will there be deprecation of support for other orchestrators like a Data Factory or Glue over time, or maybe at least less assistance? So will that happen? Are there things that Databricks can't do or won't do as part of their orchestration you need another tool for? So how are we understanding the sort of tool set comparison and making a decision there? But I think it's helpful to learn about. We'll see as it becomes live kind of what it offers and how it might fit in. We're just really about time. I'll do a quick wrap up here and leave you with a few thoughts. Hopefully it was helpful. We did our best to condense 3 packed days of a summit into about 30 minutes here. So just grab this from the keynote that was shared at the kickoff keynote, and it lays out, I guess, a diagram of what Databricks is envisioning their platform to be. And it's really all encompassing, and we've talked about a number of parts of it today. The few things that Tim and I and others are particularly thinking about: knowing your data is an asset, storing it in interoperable formats, considering governance, which has never been just a tool problem. It's always been a tool, a people, and a process problem. And how is the Unity Catalog giving more and more tool capabilities? And how do we fit in the gaps of people and process and many other things? But it's useful to come alongside Databricks vision, understand what they're going with their product and how we can best use it to deliver business value. I'll go through these pretty rapidly just to leave you with the sort of questions. I guess it'd be better to give some answers, but things we're thinking about, things we're wanting to keep exploring and understanding in the work that we're doing with customers. Tim mentioned this, I think I brought up once or twice, building versus buying. I tend to think it's often a combination of the both, and different circumstances will demand kind of give the direction, but a lot of these features are being built into Databricks, the AI features, so you can just go out and buy them and kind of configure them. Is that worth it, or do you want to have more control over it? It's a continual question, and it always has been. We definitely agree on storing data in open formats. It's no lock-in. At some point, you have to lock into some technology. At what places can you do that? What places should you do it? What technology? And then what can you do to sort of avoid too much lock-in, an inability to move or an inability to kind of call on different features? We see it. Obviously, and Tim talked about a ton of focus on generative AI investments in it, but keep a broad view of all of AI and ML. With the investments and focus going in generative AI capabilities, a ton has gone into improvements in regression and classification and say traditional machine learning. So I maintain a pretty open mindset of AI kind of fully, not just generative AI. Think about the balance of data centralization, data mesh, and I use silos there, but not quite the right word, versus other sort of architecture patterns. There's a lot of conversation around co-location of data, people, compute, legislation, and restrictions. So what is the right mashing together of where we're storing data physically and making it available to either other parts of the world or other functions or whatever it might be? Tim talked about Unity Catalog going open source. Will we see other tools enable the APIs to connect to it? I think that's a big bet that Databricks has made. I talked about this, so I'll skip it for a bit, but being able to stay up to date with all the new features of Delta Lake in the actual storage format, there's a lot that I think we can get out of just performance data storage optimization. So how do we stay up to date with them, understand them, and see where to apply them? Interesting one. It's great to see technology improving and changing and new options, but you have to pick something at some point. So how do you stay up to date with how quickly technology is moving, knowing that there might be something better tomorrow or the day after? So it's almost that battle of we almost have to make a selection or stick with a sort of practice or standard and then choose opportunistically to improve it. But there's sort of that battle of we can't just switch the next thing. We have to build out a proper platform or whatever it is. Key organizational capabilities. I was thinking about this right after the summit. The things that came to mind that you might not think about in terms of skill set: user interface and user experience design, and integration of different components, custom web design with all these different features and tools. We might need to kind of bring them together in a custom way. The ability to teach and user adoption, sharing the art of the possible. So with all this technology, how do we help people understand it so they can bring a business perspective to it? And then expertise of language, spoken language, written language, a few things that I'm thinking about building skills in. The sort of battleground of the Snowflake and Databricks and Azure or Synapse and all these other tool sets. How are we navigating that? They're often all sort of best in breed in what they do, but what's the right kind of combination for your organization? And then what does serverless mean? I talked about here at the end here. Should we apply it? Is it going to give a big benefit? In what ways? Is it for notebooks? Is it production? Is it non-production? So understanding what a migration might look like or not look like. Thank you for listening to us today. Hopefully it was helpful to get a bit of a recap from the summit and some takeaways we're thinking about. I'm happy to speak about any of these if anybody's interested. Otherwise, thank you very much again for attending. Hope you learned something today. And thank you. Take care.